Good day everyone. Our topic for today is all about factoring trinomials of the form ax squared plus bx plus c by grouping. Factoring polynomials often involves additional techniques after initial factoring out the GCF. One technique is factoring by grouping. Example. So we have factor xy plus 2x plus 2 by grouping. So notice that although 1 is the GCF for all four terms of the polynomial, the first two terms have GCF of y and the last two terms as GCF of 2. So we can have this one. For these two terms, the first two terms that we have has a GCF of y and the second two terms has a GCF of 2. Then we can factor them by y quantity x plus 1 plus 2 quantity x plus 1 and then get the GCF. The GCF of this equation is x plus 1 and x plus 1 divided y, x plus 1 is 1 times y is y plus, get the positive sign, x plus 1 divide x plus 1 is 1 times 2 is 2. So therefore, the factors are x plus 1 times y plus 2 for this particular example. Factoring a four-term polynomial by grouping. Arrange the terms so that the first two terms have common factors and the last two terms have common factors. For each pair of terms, use the distributive property to factor out the pair's greatest common factor. If there is now a common binomial factor, factor it out. If there is no common binomial factor in step 3, begin again, rearranging the terms differently. If no rearrangement leads to common binomial factor, the polynomial cannot be factored. Example. Factor each of the following polynomials by grouping. So we have this one. For this particular example, we have this group. So I think we need to arrange them. Okay. So we have this one. For x cubed, we have x times x squared. For x, we have x times 4. For x squared, we have 1 times x squared. And this one, 1 times 1. And then, okay, we can arrange them by grouping. So we have x times x squared plus 4x plus 4, I think. Okay. And then we have 1 times x squared plus 1 times 4. So the GCF is x for this group. So we have the GCF of x for this group. So if we will get x, we have x squared plus 4. And if we will get 1, we have x squared plus 4. And we can have the GCF of x squared plus 4. And the remaining numbers or variables will become x and then 1. X plus 1. So this is now the GCF. I mean the factors of this example. Okay. So we have x squared plus 4 times x plus 1. Another. So we have 2x cubed minus x squared minus 10x plus 5. So we need to factor out this example. So we have x cubed times x squared times 2x. For negative x, we have negative x squared times 1. For 5, we have negative 5 times 2x. And for 5, we have negative 5 times negative 5. Negative 1, I mean. Because negative 5 times negative 1 is positive 5. That's why we have positive 5 here. Okay? Next, we will just get the GCF of the given numbers. So we have x squared times 2x minus 1 and negative 5, I think this is negative 5 times 2x minus 1, right? So we have this 2 and then the GCF of this given will become 2x minus 1 and the remaining numbers becomes x squared minus 5. So therefore, we will multiply 2x minus 1 times x squared minus 5 to get these equation. Okay? So this is the factors of this particular equation. Another factor 2x minus 9y plus 18 minus x, y. Okay, so neither pair has a common factor other than 1. So rearrange in the order of the factors. So we have 2x plus 2 times negative 9 times y minus x, y. So the factors are 2 and y for this group. So we will have groupings. For this group, we have this one. And for this group, we have y as the factor. So we have 2 times x plus 9 and negative y times 9 plus x. Or x plus 9 and 9 plus x are just the same, I think. So the GCF is 9 plus x or x plus 9. Okay. Make sure the factor are identical. So we made them identically the same. So we have x plus 9 and 2x minus y as the remaining variables. So that is the factors. So these are the factors of the equation that we have in our given. Okay, that's it. For factoring trinomials of the form ax squared plus bx plus c by grouping. With that, thank you very much for listening.